What if humans looked completely different in the far future? How might evolution, technology, and lifestyle reshape our bodies and perceptions of beauty? As humanity evolves, driven by changes in environment, technology, and lifestyle, our physical appearance and even brain structure could shift dramatically. Scaling laws, biological principles that relate size, shape, and function will play a key role. For instance, colonizing planets with different gravity might make us taller and leaner in low gravity, or shorter and sturdier in high gravity. But lifestyle changes on Earth are already shaping our evolution, and these effects could become even more pronounced. In a future dominated by less physical work and more sedentary, office-based lifestyles, our bodies might adapt to these changes. We could see narrower waists and weaker muscle tone as physical exertion decreases. Our hands might evolve to better suit fine motor tasks like typing and screen interactions, potentially elongating fingers for precision. Meanwhile, prolonged screen exposure could lead to larger eyes to accommodate digital environments, altering facial proportions. Our brains might also change. As artificial intelligence and automation handle repetitive tasks, human cognition could prioritize creative, strategic, and social thinking, possibly resulting in a larger prefrontal cortex. Conversely, reliance on external technology might reduce memory capacity or the need for spatial awareness, leading to changes in overall brain size and structure. Cultural and technological influences will also redefine perceptions of beauty. Genetic engineering might allow customization of physical traits, creating diversity in appearance, traits that reflect functionality, like a posture adapted for prolonged sitting or eyes optimized for digital environments, might redefine attractive. The humans of the far future will likely be shaped by the environments they inhabit and the lifestyles they lead. Whether taller and leaner for space colonies or adapted for an increasingly technological Earth, our future selves will reflect a blend of evolution, innovation, and societal norms, reshaping not just our bodies, but also what it means to be human. Human evolution is a continuous process influenced by environmental factors, cultural practices, and technological advancements. As lifestyles become increasingly sedentary, with less physical labor and greater reliance on technology, the forces driving evolutionary changes are shifting. In contrast to past millennia, where survival depended on physical strength, endurance, and adaptability to harsh environments, modern humans are increasingly shaped by intellectual challenges and technological dependency. Scaling laws, which predict how physical traits adapt to size and function, will guide these changes, influencing proportions, metabolism, and brain development over generations. Studies comparing hunter-gatherer populations to agricultural societies reveal significant reductions in bone density and muscle mass, illustrating how lifestyle changes directly affect human anatomy. The human body's adaptation to modern living can be likened to a machine reprogrammed for efficiency. Its core functions remain intact, but its form evolves to meet new demands. A sedentary lifestyle significantly reduces the need for physical strength and endurance, leading to a gradual decline in muscle mass and bone density. Over generations, scaling laws suggest body proportions may evolve to favor longer limbs and narrower torsos, optimizing energy efficiency. The reduction in physical strain could also result in less robust skeletal structures, making future humans more susceptible to fractures and injuries. He had a lot of pictures that had like bloody hands, and he was a young scientist, and there was a lot of scarring, and this trend might be counterbalanced by increased fat storage as the body adapts to lower caloric needs, but higher caloric intake typical of modern diets. Consequently, more homogeneous body shapes could emerge, with extremes of physical robustness or thinness becoming less advantageous. A similar effect is observed in astronauts, who lose bone density in microgravity environments due to reduced physical stress, mirroring the skeletal changes linked to a sedentary lifestyle. The adaptation of human bodies to these conditions is akin to skyscrapers with lighter frameworks, functional but less durable under stress. The evolution of the human brain is shaped by energy availability, cognitive demands, and environmental challenges. In a future increasingly dominated by automation and artificial intelligence, the reliance on problem solving and manual memory tasks may decline, potentially leading to a reduction in brain size or a specialization of neural functions. Enhanced neural plasticity might evolve, allowing quicker adaptation to technological interfaces, but overuse of digital tools could cause atrophy in cognitive areas related to spatial awareness, memory retention, and deep focus. Over time, humans may develop brains optimized for multitasking, collaborating with AI, and rapid decision-making, rather than deep critical thinking. Research on prolonged screen time indicates changes in brain connectivity, particularly in regions associated with attention and decision-making, highlighting how lifestyle shifts can impact neural structure. This evolution is akin to transforming a traditional library into a digital archive. It retains its core functions but loses its original form. Modern habits like prolonged sitting and frequent screen use are already reshaping posture and skeletal alignment, with potential long-term evolutionary effects. Over generations, these habits could result in forward-leaping necks, curved spines, and compressed chest cavities. Pelvic structures might adapt to extended sitting, altering gait and mobility. Scaling laws suggest that skeletal structures may become lighter and more energy efficient due to decreased physical demands, though this could lead to chronic issues such as reduced flexibility and joint stress. The prevalence of conditions like Tex neck syndrome and lower back pain in today's populations highlights how these immediate effects could evolve into permanent changes. This transformation is similar to a building settling over time, where persistent stress causes subtle yet irreversible shifts in structure. Reduced physical activity and dietary shifts in sedentary lifestyles decrease overall energy demands, potentially leading future humans to develop slower metabolic rates to conserve energy, along with smaller hearts and lungs to match reduced oxygen needs. However, these sedentary habits also heighten the risk of obesity, diabetes, and cardiovascular diseases, which could drive selective pressures for genes that enhance metabolic resilience and fat regulation. While advances in medical technology might mitigate these risks, natural evolution may still favor traits that improve endurance against modern health challenges. Populations in Arctic regions, for example, evolved to efficiently store and metabolize fat due to historically scarce food resources, illustrating how metabolic traits adapt to environmental pressures. These adaptations resemble energy-efficient appliances that consume less fuel but function at a slower pace. The prevalence of digital environments is driving changes in sensory systems. Prolonged screen use promotes adaptations in vision, such as increased nearsightedness and enhanced focus on close-range tasks. Hearing may become attuned to artificial sound ranges, while touch sensitivity could diminish due to reduced interaction with natural surroundings. Scaling laws suggest that sensory systems might evolve to optimize for digital stimuli, potentially diminishing capabilities like depth perception or fine motor coordination in favor of virtual interactions. The rising rates of myopia in urban populations linked to extensive screen use and limited outdoor activity exemplify how technology shapes sensory development. These adaptations are akin to redesigning a car dashboard for city driving, prioritizing immediate utility while compromising long-range functionality. Perceptions of beauty change in response to cultural and environmental shifts. In sedentary societies, traits signaling health, efficiency, and compatibility with technological lifestyles may gain prominence. Symmetry, clear skin, and lean builds are likely to remain popular, but advancements in genetic engineering and augmented reality could redefine beauty ideals. Future standards may prioritize a balance between natural biology and technological enhancement, reflecting societal values of the time. Historical examples, such as the preference for robust figures during periods of food scarcity, show how societal and environmental factors shape beauty norms. These evolving standards are akin to trends in architecture, where each era mirrors its unique priorities, values, and available resources. So you could wear smock, you could wear tight, you could wear trousers. I love it. And you could have remote conversations with people you didn't know in person, and they're like, what the fuck are you talking about? Who are these people? As technology becomes increasingly intertwined with daily life, its integration with human biology is likely to accelerate. Neural implants, wearable devices, and bioengineered augmentations could enhance or even replace natural functions, driving a new phase of evolution where biological traits are supplemented or rendered obsolete by technological advancements. This transformation might lead to hybrid humans, with physical forms optimized for interaction with technology rather than natural environments. Brain-computer interfaces currently in development, enabling direct communication between the brain and external devices, exemplify the potential for fully integrated human-machine systems. This integration is akin to upgrading a classic car with modern features, retaining its core essence while adding enhanced capabilities. Significant evolutionary changes typically require thousands of generations, but rapid technological and cultural shifts could accelerate the process. Over millennia, humans may diverge into distinct subspecies adapted to varied lifestyles and environments, such as urban centers, space colonies, or underwater habitats. Scaling laws suggest these adaptations will prioritize efficiency and specialization, leading to diverse forms shaped by unique ecological and societal demands. Genetic engineering and artificial selection may further influence this trajectory, allowing for rapid and deliberate evolution. For instance, space colonists might develop elongated limbs and reduced bone density in low-gravity environments, illustrating how environmental factors drive anatomical divergence. The evolution of humanity's future is like branching rivers, where each path follows its environment, creating diverse outcomes. This is the future of human evolution will be shaped by sedentary lifestyles, technological integration, and environmental changes. Scaling laws and selective pressures will influence body proportions, metabolic rates, brain function, and beauty standards. Whether through natural evolution, genetic engineering, or technological augmentation, humanity's physical and cognitive traits will adapt to an ever-changing world, reflecting the dynamic interplay between biology, culture, and innovation. Understanding these possibilities enables us to better prepare for and shape the next stages of human development.